Welcome to Kyvos training. In this session, you will learn how to design a Kyvos semantic model. In video, we will be discussing semantic model basics, which includes understanding semantic models, creating measures, creating dimensions, defining hierarchies, defining attributes, defining levels, adding regular time and location dimension types. A semantic model provides a consistent way of analyzing data. It maps complex data into familiar business terms so that users across the enterprise can access the same source of truth with full confidence in its integrity. Creating dataset relationships is a prerequisite for creating semantic models. Broadly, a semantic model represents business data in terms of qualitative fields known as dimensions and quantitative fields called measures. Dimensions are arranged in the form of hierarchies and attributes. Hierarchies can have further multiple levels. Measures, on the other hand, can be derived from original quantitative fields or from calculations. Measures are aggregated for cross-combination of all dimension fields, which helps in ad hoc analysis at high speed. Before we begin, let's understand about types of semantic models. Kyvos supports two types of semantic models: the base model and the perspective model. You can think of the base model as the foundation of your analytics layer. It defines your core business logic, measures, and dimensions. Everything required to generate meaningful insights. In this video, we'll be working with a base model, and by the end, you'll know exactly how to design one from scratch. Let us start designing a Kyvos semantic model. Log into the Kyvos portal. Start by expanding the toolbox menu and click on the semantic models. Click the Actions menu to add a new folder. Now, click the Actions menu again and select Add Base Model. Select the relationship Adventure Works Trial. For this training, we will design a semantic model that depicts sales orders data. Click Add. This will open the Semantic Model Designer workspace. The Designer workspace has three sections. First is the Source Field panel. This panel shows all the fields from the relationship datasets. These fields are candidates for the creation of semantic models. Second is the Design panel, which consists of two subpanels, one each for dimensions and measures. This is where the semantic model design will unfold. And last is the Properties panel, where we can configure the properties for any selected field. It also consists of a Filter panel that lets you filter the fields on the Design panel. There is also an AI Settings, Refine Model, and Process tab that we will cover in the different sessions. Now let's begin designing our semantic model for analyzing order data. This model will provide analysis over the fields: order quantity and sales amount from the fact sales table. Let me show you how to add these measures to the semantic model. Go to the Candidate Measure section and expand fact sales. Now select Order Quantity field and drag it to the Measure panel. The order quantity measure is created with default function as sum. Similarly, we will add sales amount as another measure. And if you ever want to change how this measure is calculated, it's really simple. Just click the measure, head over to the Properties panel on the right, and open the Aggregation function dropdown. From here, pick what you need: sum, average, min, max, or count, and Kyvos will instantly adjust how the measure behaves in your analysis. In addition to these standard aggregation types, Kyvos also supports semi-additive functions, which are used to identify the first child, last child, first non-empty child, or last non-empty child for a specific duration. Next, let us add a dimension to the model. Each dimension is a logical grouping which represents the qualitative information of the data. Generally, fields from the dimension table are used to create dimensions. Let us create dimensions for product, order date, and customer location. Go to the Dimension panel and click on the plus sign to add a dimension. You can see a dimension is created with hierarchy and attributes. Let us rename the dimension as Product by right, clicking on the dimension and selecting Rename option. Let us create a hierarchy in the Product dimension. Hierarchies are created in the dimension mainly for two business requirements: to see the data with parent-child relation, and to enable drill up and drill down functionality. Now go to Candidate Dimension section, expand dim product, select Class Description field and drag it to the level under Product Hierarchy. Similarly, let us add English Product Name field as another level to the hierarchy. Now we will add attributes to the product dimension. We generally create attributes for the fields not expressed in the form of parent-child relation and are needed as a direct field for analysis. Now go to Candidate Dimension section. From Dim Product List, select Color and drag it to the Attributes section of the product dimension. Similarly, we will add two more attributes, namely Size and Product Line. Now let's talk about a few more useful options you'll find when working with dimensions: hiding columns, processing metadata, and adding descriptions. Sometimes a dimension column, whether it's a level or an attribute, is used only for internal calculations and doesn't really help business users during analysis. In those cases, you can simply hide it from the Kyvos UI. Hidden fields won't appear in worksheets or third-party tools, but you can still see them on the Semantic Model Designer page. To hide a dimension column, just pick any attribute from the dim product table. For example, product line. When you click it, the Attribute Properties panel appears on the right. Here, scroll and uncheck the Visible option to hide it, and check it again if you want to show it. And you can also click the little info icon if you want to learn more. Now moving on, and let's look at processing metadata for attributes. Right below the Visibility option, you'll see a setting called Materialization, and it gives you two choices. Keep data. When this is selected, Kyvos creates a cuboid for this attribute. If you open the Show Advanced options, you'll also see Include in Query-Based Aggregates. This allows Kyvos to generate smart aggregates based on queries. If you turn this off, those query-based aggregates won't be created. Keep metadata. This option instructs Kyvos to generate metadata for the attribute while processing the semantic model. It is especially useful when the attribute is frequently used in analysis, because metadata helps improve query performance. So, based on how important the attribute is, you can pick the materialization option that fits your needs. Finally, let's look at the description option, the one just below materialization. Here you can add a meaningful description for the attribute. Think of this as a place for business definitions, logic details, usage notes, or any context users may need. It helps make the semantic model richer and easier to understand. Tagging will be covered in the upcoming video. We have created the product dimension, which is a regular type dimension. This is the default setting of the dimension, which makes no assumptions about the contents of the dimensions. Now we will create a time type dimension. A time type dimension represents the time information like year, quarter, month, etc. It is recommended that there should be at least one time type dimension in the semantic model. This will help in partitioning the model for faster query responses, time series analysis, and managing the semantic model data. There are three different ways to create hierarchy of a time type dimension: a predefined hierarchy, a custom hierarchy, and a custom calendar. You can choose any one of the ways to create the time type dimension. Let us create a time type dimension using predefined hierarchy. Click on the plus sign to add a new dimension and rename it as order date. Designers prefer to use this way to design a time type, as it is the easiest way to design time type dimension. Now, click on the Type drop-down field in the Dimension Properties panel and select Dimension Type as Time. Now select Order Date Hierarchy under Order Date Dimension. On the right, under the Hierarchy Properties panel, click on the Hierarchy drop-down menu and select Year, Month, Day. Now click on the Field drop-down to select the Date data type as Full Date Alternate key from the dim date. You will see three predefined hierarchy levels, Year, Month, Day, will be automatically created for Order Date Dimension. Now, let's see how to create a time type dimension with custom hierarchy. Designers prefer to use this way of design when there is a requirement to see the time period fields in specific desired date format. Go to the Dimension panel. Click on the plus sign to add a new dimension and rename it as Custom Order Date. Click on the Type drop-down menu in the Dimension Properties panel and select Dimension Type as Time. Now go to Candidate Dimension section. From Dim Date Dataset, select Calendar Year field, which has values in the supported format YYYY. Now drag it to the level under Custom Order Date hierarchy. Click on the Date Data Type drop-down field in the Properties panel and select Year. Now we will add Quarter Level to the hierarchy. From Dim Date Dataset, select Calendar Quarter field, which contains values in either of the supported formats, such as Q1, Quarter 1, 1, or 01. Drag it under the Calendar Year level of the Custom Order Date hierarchy. In the Properties panel, click on the Date Data Type dropdown and select Quarter. Next, we will add Month level to the hierarchy. From Dim Date Dataset, select Month Number of Year field, which contains values in either of the supported formats, such as John, January, 0, 1, or 1. Drag this field below the Calendar Quarter level of the Custom Order Date hierarchy and mark it as Month in the Date Data Type dropdown in the Properties panel. Next, we will add Week level to the hierarchy. From Dim Date Dataset, select Week Number of Year field, containing values as W1, 01, 1, or Week 1. Drag this field below the Month Number of Year level of the Custom Order Date hierarchy and click on the Date Data Type dropdown to select Week. Lastly, we will add Day level to our custom hierarchy. From Dim Date Dataset, select Day Number of Year field with values in the format 0, 1, or 1. Drag this field below the Week Number of Year level of our Custom Order Date hierarchy and select Day in the Date Data Type from the dropdown. This creates a custom hierarchy for our Time Types dimension. Now let's see how to create a Time Type dimension with Custom Calendar. Designers use this way of designing the Time Type dimension when there is a requirement to see the date calendar as per different financial calendar. Go to the Dimension panel and click on plus icon to add a dimension. Rename it as Custom Calendar Order Date. In the Dimension Properties panel, select Time as the dimension type in the Type drop-down menu. Now select the Hierarchy Custom Calendar Order Date and check the Custom Calendar checkbox in the Properties panel. Go to Candidate Dimension section and from Dim Date Dataset, select the Date Data Type field named Full Date Alternate Key. Drag it under Custom Calendar Order Date hierarchy. Now click on the Display field dropdown in the Properties panel and select Fiscal Year from Dim Date. Then click on the Date Data Type dropdown in the Properties panel and select Year. Similarly, we can add a month level to our hierarchy. From the Dim Date dataset, select and drag the Full Date Alternate Key field again, below the Fiscal Year level of the Custom Calendar Order Date hierarchy. Now click on the Display field dropdown in the Properties panel and select Month Name from Dim Date. Click on the Date Data Type dropdown and select Month. Lastly, we will add a day level to the hierarchy. Select and drag the Full Date Alternate Key field again, below the Month Name level of the Custom Calendar. Order Date hierarchy. Click on the Display field dropdown in the Properties panel and select Date Key from Dim Date, and then click on the Date Data Type dropdown and select Day. This creates a Time Type dimension using Custom Calendar. Now let's see how to create a Location dimension. This type of dimension depicts the geographical information like continent, country, state, city, county, and postal code so that it can be used in the map chart. Let's add a new dimension by clicking plus sign in the Dimension panel and rename it as Geography. Click on the Type dropdown in the Dimension Properties panel and select Dimension Type as Location. Now in the Candidate Dimension section, expand Dim Geography dataset and select English Country Region, name field which has country names as values. Drag the field to the level under the Geography hierarchy and rename the level as Country. Now click on the Role drop-down field in the Properties panel and select Country. Then click on the Map Level drop-down and select World Countries. Now we can similarly add Province level to the hierarchy. In the Candidate Dimension section, select the State Province Name field, which has U.S. province names as values. Drag it below the country level under Geography hierarchy. Rename the level as Province. Now click on the Role drop-down field in the Properties panel and select Province. Then click on the Map Level drop-down and select U.S. Region. We will repeat the process again to add city level to the hierarchy. Select City field containing values of U.S. city names from the Candidate Dimension section. Drag it below the Province level of Geography hierarchy. Rename the level as City. Now click on the Role drop-down field and select City. This completes our location hierarchy. Click on the Collapse All button to condense the view. You can also delete a dimension if it is no longer required. To do so, right-click the dimension and click Delete. Once you are satisfied with your design, click on the Save button. We are saving this design as Adventure Works Sales Analysis. This marks the end of our session on designing semantic models in Kyvos. Thank you.